So in this particular lecture, we are going to have a look at our third topic, and that is going to be quadratic equation. Now, from point of view of CAT, quadratic equation is very, very important. We see questions very often and almost regularly, I would say. When I talk about quadratic equation, just like linear equation that we talked about in the last lecture, your degree is 1 in linear equation. In quadratic equation, your degree is 2. What does that mean? That means the variable is going to have a power of 2. So if this is the equation, let's say ax square plus bx plus c equals to 0. Now this, you see, is a quadratic equation. Why so? Because it has a degree of 2. The power that you see that x is having highest is 2. That is why it is a quadratic equation. Making sure that a is never equals to 0. Because you see, if a becomes a 0, then the equation will be bx plus c, which is not a quadratic equation, It is a linear equation. So that is why a can never be 0. Whenever you have a quadratic equation or any other equation, whatever its degree is, it has similar number of roots. So if its degree is 2 in this case, it will have 2 roots. Now what are roots? I will tell you, do not worry about that. Okay, so this is going to have 2 roots. You can write that down for now. I will explain it very clearly if you don't know. Second thing, this is one thing. And second thing is that graph of quadratic equation is parabola. Okay, so you have an equation and its graph is parabola. How does a parabola look like? Let me show you. This is your y, this is your x-axis, this is your y-axis, and how does the parabola look like? Parabola look like something like this. Here, this is a parabola. A U-shaped kind of a thing, but not exactly U, but opening on the both the sides. U is like this, but parabola is like this. Now this could also be a parabola, right? But this is actually how parabola looks like. Okay, so there is your parabola. There is one very interesting thing comes into play when you draw the graph of the quadratic equation. When you draw a parabola, a very nice thing comes into play, and that is that if the graph looks like this, then in that case a is greater than 0, or opposite to that, vice versa, that if a is greater than 0, then graph will look like this, the parabola will look like this. And if a is less than 0, in that case your parabola will be like this. We will see how to draw a graph and all of that, but this is how it looks like. So whenever your a from here, whenever this a is greater than 0, the shape is upwards. The mouth opens upwards. But if a is negative, in that case, the mouth opens downwards. Okay, so this is one thing that you need to remember. Let's get back to the equation. We have the equation ax square plus bx plus c equals to 0. Right, this is our equation. Now, whenever you need to make the factors, because this is going to have some factors, right? Just like in linear equation, they have factors. That means that it satisfies the equation. That is what roots are. If I say this has alpha and beta roots, okay, alpha is some number, beta is some number. So that basically means when I put this alpha in place of x, this equation will be equal to this. In our case, it is 0. So when I put alpha in the place of x, it will be 0. Or if I place beta in place of x, it will become 0. So that is what I'm saying. Let's get back. Let me write down that equation again. Ax square plus bx plus c equals to 0. This is the equation. Whenever you need to find the roots or whenever you need to adjust the factors, you always multiply a with c from this equation. This is for what? This is for your factor adjustment. Okay, and this b that is a and c are for factor adjustment, and b is for your addition or subtraction. Now, what is that? How does that work? We will discuss all of that in the coming few minutes. But this is just an outline that I wanted to tell. This you need to know for now, that whenever I have to adjust the factors, I'll be using A and C. How? Let's quickly see an example for this. Let's say I have this equation x square plus 7x plus 12 equals to 0, and now I need to find the roots of this equation. So how will I adjust the factors? I will take a and c from this. A is what? A is 1, right? Since you have no number, so it will be 1 multiplied by x square. So a is 1. B is what? Compare. Compare. A is 1, B is 7, and C is 12. So for factor adjustment, we take A and we take C. So that it AC is 12. Right? So the product we have got, and it is 12. How can this be divided? It can be 1 comma 12, 2 comma 6, 3 comma 4. These are the three numbers that we can get. Either the pair could be 1 comma 12, or it could be 2 comma 6, or it could be 3 comma 4. This is what we are having. Now look, which of them gets to a total of 7? Because that is B. So we need to know which of them gets to a total of 7. Does this get there? No. It is 1 and 12. So either it could be 13. Or if we take minus 1 comma minus 12, so that would be minus 13. Similarly here, this would be 8. But this, if you see, this is 7, which is our B. So we will write this equation as x square plus 3x plus 4x plus 12 equals to 0. Just we have divided this 7x into two parts, of which sum is of which the product 3x multiplied by 4x is equals to this multiplied by this. Right? You're getting it? 7x is getting divided into 3x and 4x. So we could write this equation as x times x plus 3. Let's take 4 common from here. So it will be again x plus 3 equals to 0. So this would be x plus 3 multiplied by x plus 4 equals to 0. So from here, x plus 3 would be 0, or x plus 4 will be 0. So x will be minus 3, or it will be minus 4 from here. Right? And this is what we were talking about. These are two roots of the quadratic equation that we are having, and this is how you find the roots. So this was our equation, x square plus 7x plus 12. We divided 7x into two parts such that their product is equals to product of these two. So that is why a multiplied by c, which was 12, we divided it into 3 comma 4. So it was divided, we took x common from these two, 4 common from these two, it became this, then x plus 3 take common, and it would be x plus 4. So this came x plus 3 0 or x plus 4 0. So x is minus 3 or minus 4. This is what we need to know. If you have any questions, you can drop it in the comment section and I will answer that. Okay, let's see more. Let's say you're already given that x equals to a and x equals to b are the roots of the quadratic equation. Okay. Then if this is given, in that case, then x minus a and x minus b will be the factors of that quadratic equation. Factors of that quadratic equation. Because what are factors? Factors are something that can divide a particular thing, right? So here if you see, we have minus 3 and minus 4 as roots. So x minus a, that means x minus minus 3. So that would be x plus 3. Similarly, x plus 4 equals to 0. Now since their product is 0, so that means x plus 3 is a factor. X plus 4 is a factor because x is minus 3 and x is minus 4. So x minus minus 3 will be x plus 3 and x minus minus 4 will be x plus 4. Hope that makes some sense. So this is something that you will have. Okay, just something that can ask questions from you. So that is why I'm telling you this. Let's see. Let's have a look at one example. Let's say you're given an equation 2x square minus 11x minus 76 equals to 0. Now again we need to find the roots of this equation. So how do we do it? A is 2, B is minus 11 and C is minus 76. So AC is 2 multiplied by minus 76, so that is minus 152. Let's have a look at factors of this. So it would be 2, 2, 38, 2, 19, 19. These are the factors. Now look at these. Where can you see a combo which makes minus 11? Just try to find it out. This 2 multiplied by 2 multiplied by 2 and this 19. This could make 8 and this could be 19. And B is minus 11. So can we take minus 19? Because their product is going to be minus 152 and that is what we need. Yes. So we could write this equation as 2x square minus 19x plus 8x minus 76 equals to 0. So this would be x taking common. 2x minus 19 plus 8 x, oh sorry, 4 is common. Let me erase this. Plus 4, 2x minus 19 equals to 0. So that would be x plus 4, 2x minus 19 equals to 0. So x would be minus 4 from here and here it would be 19 by 2. And these are the roots of the equation. Let's see how to draw a graph. Let's go back to a simpler equation that we had earlier. So I am having x square plus 7x plus 12 equals to 0. This was having roots as -3 and -4. We just solved it here. Yeah. So this is having roots as -3 and -4. So basically this what this means is that this is how its graph will be. That is x equals, this is a y-axis, this is a x-axis. This is 0, this side positive, this side negative. Right? This is how our graph is. So now we are basically saying that at x equals to -3 and at x equals to -4, the graph will be 0. That is what roots are. That if you put -3 or -4 into this, it would make the equation as 0. So that is what I'm going to do, that if it is -3 or -4, it will be 0. So I have got 2 points. Okay. Now it is going to be a parabola, since quadratic equation is always a parabola. So excuse me. So either the equation would look something like this, or the equation would look something like this. Sorry, the parabola will look like this. I told you just a few minutes ago that if a is greater than 0, in this case a is 1, so a is greater than 0, so parabola will be like this. And since here on the y-axis x is 0, as you can see here, so if we put x equals to 0 in this, so it will be 0 squared plus 7 multiplied by 0 plus 12. So 0 plus 0 plus 12, so that is going to be 12. So that means this point will be 12 or 0 comma 12. X comma y. So x is 0, right? We have put that, and y is 12. So these are the points that are really important. -3 and -4, which are roots. So just keep them there and make your parabola, passing through that. So basically what I'm saying is, if you have an equation ax squared plus bx plus c equals to 0, and it has roots alpha and beta, in that case, if a is greater than 0, then your graph will look something like this, where this would be alpha, this will be beta. Yeah. Now the graph could shift more towards left or more towards right. Like in this graph shifted more towards left. Okay. And similarly, if a is less than 0, alpha, beta are roots, so it would go like this. Got it? Now, look in this equation. This is y-axis, this is x-axis, this is y-axis, and this is x-axis. So this part that you see, since this is 0, right? Let me write it with a different pen. Right? So if this is 0, that means whatever goes below this, y is negative, right? So this part that you see in this, y is negative. Here it is positive, here positive, positive, negative, negative. I'm talking about y. So let's call this case 1 and let's call this case 2. Sounds good? Now we have the equation y equals to ax square plus bx plus c equals to 0. Roots are alpha and beta. So if roots are alpha and beta, then factors will be x minus alpha and x minus beta. So that means I can write it like this. Yes. Now in case 1, when is y greater than 0? Have a look in this part and in this part. right? Which is basically before alpha. So that is when x is less than alpha. And here, when x is more than beta. So when is x is greater than beta. And when is y less than 0? When x is from alpha to beta. Alpha to beta. Similarly, if you see in case 2, y is greater than 0 when x is from alpha to beta, so it reverses the condition, and x is greater than beta. You can check it here. Compare and see. Excuse me. I'm having a bad throat and I'm not going to edit the video, so I hope it's fine with you. Okay, so this is how this will look. Now let's see and solve another question. Let's solve a similar question for this. So let's say if I have a question 2x square minus 11x minus 76, and I need to find when it is greater than 0. So solve for x. That basically means find the values of x for which this equation is true. So let's solve this. 2x square minus 76, we just saw that it will be 2 multiplied by minus 76, so minus 152. We found out that it could have 8 and minus 19. So it would be something like this. This is the equation that we got, right? I could show you if you don't believe me. Here, right? Okay, this was x plus 4. Yeah, I took it x plus 4. Correct. So now that means that okay, I need to remove the 2 as well. I could have taken that into account, but to make things easier for you, let's remove that. X minus 19y2, x plus 4 greater than 0. Cool. Let's draw a graph. Minus 4 somewhere here because negative 0 is here, y-axis, x-axis, so x equals to minus 4 is here, and from this another root is, so root are minus 4 and 19y2, right? So let's say this is 19 by 2. Okay, it should be far away somewhere here. Is a greater than 0? Yes, a is 2, so it should be greater than 0. So parabola is going to look something like this. And if we put 0, x equals to 0 in the equation, then it would be minus 76, the equation. So this point will be, for y it will be minus 76. Sorry. Now look, we need to find when is the equation greater than 0. We need to find that. So let's see. Is it case 1 or case 2? In case 1, a is greater than 0. So that is y is greater than 0. So that means x less than alpha and x greater than beta. So x less than minus 4 and x greater than 19 by 2. This is how everyone does, that they remember the cases, but you don't have to. Just have a look at the graph. This is 0. Above everything, above this 0, y is positive. So this is positive. This is positive. And when it is happening? It is happening when x is less than minus 4. From 4 to 19 by 2, it is all negative. Right? Below the x-axis, below that line, it is all negative. but I need only positive. That is only happening when x is less than -4 and x is greater than 19 by 2. So that means x starts from infinity, it goes till 4, union, and that means and it starts again from 19 by 2 because it is greater than that, and it goes till infinity because this parabola that you see is going till infinity. That is what I'm writing. Let me show you one more example and things will become much more clear. You have x square plus 13x plus 40 less than 0. Solve for x. Let's see. What's A? 1. B is 13. C is 40. Correct? So AC is 40. A is greater than 0. These are the things we need. AC is 40. Let's write down its factors. So 2, comma 2, comma 2, comma 5. Now make such a pair of the products in this that the total is 13. So can you see this 2, 2, 2, 2? The product is 8. 2 multiplied by 2 multiplied by 2 is 8. And this is 5. So 8 multiplied by 5 is basically 40. Also their sum is 13. The B that we need. So can we write this equation as x square plus 8x plus 5x plus 40 equals to 0? Let's take x common. In this, let's take 5 common. This would be x plus 5. X plus 8 equals to 0. So the roots will be -5 and -8. Here. This is the line. -8, -5. When it's the graph above the line. Here and here. But we needed negative, right? Less than 0. So it should be below the line. So this part is below the line. So x will be from -8 to -5. Right? This is how you can solve such kind of questions. Really easy. They will come in CAT for sure, not directly, but in a way. Let's move further and let's see a few more things. Again, here's our equation: ax square plus bx plus c equals to 0. The roots are x equals to alpha and beta, right? If roots are alpha and beta, that means factors are x minus alpha and x minus beta. Yes. So let's expand this equation. So this will be x square minus alpha plus beta multiplied by x plus alpha beta equals to 0. This is going to be the equation. Let's compare this equation, first equation, and this second equation. From equation 1 and 2, what we get is alpha plus beta is equals to minus b by a. First thing. Alpha beta is c by a. Second thing. These are the two things that we get from by comparing equation 1 and equation 2. If you see this is nothing but sum of roots, alpha and beta. And this is nothing but product of roots, c by a. Got it? That means if I need to rewrite an equation, I can write it as x square minus sx plus p equals to 0. S is sum, p is product, and if you compare it with this, you can see that alpha plus beta is sum, alpha beta is product, and that is what I have written. I hope this makes some sense. Again, if you have any questions, if you have any doubt, you can ask in the comments. Otherwise, this is something about roots. Let's discuss a few more things. Again, same equation, ax square plus bx plus c equals to 0. Cool? Now, there is something called discriminant. Discriminant, which is usually represented by d, and you can find it with the formula of b square minus 4ac. Okay, so this is something which is very, very important, that d equals to b square minus 4ac. Now, this basically gives us nature of the roots of the equation. So until now we were finding roots of the equation, right? But how does it give nature of the roots? We will see this with the help of discriminant. But how? Whenever this b square minus 4ac, that is this d, becomes equals to 0, that is b square minus 4ac, whatever the values are a of a, b and c are, when this becomes 0, roots are real and equal. When this is greater than 0, you have two real and distinct roots. When d is 0, here in this case, roots are real, that's for sure. Okay, it will have some number or something in decimal, but they will be equal. But when d is greater than 0, that is b square minus 4ac is greater than 0, in that case roots will be real, but they will be distinct. They both will be different from each other. That is something that you need to know. Okay, let's see. If d is less than 0, in that case roots are imaginary. What's that? What are imaginary roots? We will discuss that also. Do not worry. Okay, but yeah, these are the three things that you need. There is one more nuance to this, and that is if d, that is your discriminant, if that is a perfect square, in that case your roots are rational. So let's say if in a question you are given that your roots are rational, then try to make your d, that is discriminant, as a perfect square. Okay, now here your d is 0, here it is greater than 0, and here it is less than 0. So basically what this means as compared to your roots is that if I am drawing a graph where d, that is your discriminant, where that is equals to 0. So what is written here? Roots are real and equal. So that means whatever my roots are, it is the same root. So at the same position, alpha and beta are present. Something like this. And this is only possible when my graph just comes, that the parabola just comes and it touches the x at one of the points. So alpha and beta, not alpha comma beta, that wouldn't be right. Alpha comma beta. No, again, not this. Alpha equals to beta, which is basically the same point. That's what I'm trying to say. Let's say this is the equation x square plus 4x plus 4 equals to 0. So this is basically a perfect square if you see. And in this you have two roots. And they both roots are equal -2 and -2. So when you draw a graph of a parabola, you only have -2. So you will have to draw your parabola like this at point -2. This is what I'm talking about. And when you have d greater than 0, that means two real and distinct roots. That means I have this y-axis, I have this x-axis, and two real roots and different, distinct. This time your graph will be like this, alpha, beta. If d is less than 0, this is the graph. In this case, you will have imaginary roots. The parabola will not cut anywhere on x-axis. It will be something like this. In all the situations, we have a greater than 0. If a is less than 0, then we will make it like this, and graph will be something here. Okay, so since roots are imaginary, we do not know the value of x, so we write it like this. Okay, just one quick thing. If you have this equation, a quadratic equation, any equation at all, then you can find its root or the value of x with this formula, minus b plus minus root of b square minus 4ac upon 2a. So if you have x squared plus 4x plus let's say 313 equals to 0, if you have this equation, a is 1, b is 4, c is 3, and you want to find the roots, then you can just put these values here. This is plus minus, so one time use plus, second time use minus, so you will get two values of x, and those two values of x will be the roots of the equation. So you can try it out, put the values, then use the simple method that we use, the product thing, where we multiply a and c and then we go ahead. So try both the things, right? Firstly try with this and then compare it with that, so that you will have some idea that okay, this is how it is working. Now let's discuss imaginary roots. Now imaginary roots are of the form a plus minus ib, where I is equals to root of -1, which basically stands for imaginary, and it is of the format this, a plus ib and a minus ib, where a could be anything, b could be anything, just a random thing. It is not related to this equation, so don't confuse it with that this a and this b are this. No, these are different, right? You could choose some other variables if you are getting confused. You could write k plus ib, right? Or k, or this would be better, x plus minus iy. You could use this. Okay, let's see some more things in this. imaginary roots that you have, imaginary roots always occur in pairs, always occur in pairs. So if one is a plus ib, another will be a minus ib. Okay, so if one first root of the equation is this, then another has to be this. And this occurrence we call this conjugate roots. That if one is a plus ib, then another is going to be a minus ib. Or if it is one is a minus ib, then another will be a plus ib. Okay. Uh, Therefore, only one root of the equation of the quadratic equation cannot be imaginary. Why? Because they occur in pairs. So either both will be there or none. Either or both two of them or none of them. Because it occurs in conjugate pairs. So either it will be a plus ib, a minus ib, or they will be real. If it is imaginary, it will occur in pair. They both will be imaginary. Okay. I should write only one root of the equation. Better English. Yeah. So only one root of the quadratic equation cannot be imaginary. Either both will be imaginary or none of them will be. I hope the reason is pretty clear to you. So this is what imaginary roots are. Now let's solve some questions to get better at this. So let's say if you are given if 3x square plus 4x plus 5 equals to 0 and ax square plus 7x plus c equals to 0 has at least one common root, find c minus a. That is the question. So you can pause the video and try to solve this. Let's see. They have at least one common root, right? So I have this equation 3x square plus 4x plus 5 equals to 0. Let's see what is the discriminant of this. Discriminant can be found with b square minus 4ac. Yes, we saw this. B is 4, so 4 square minus 4 times a is 3, c is 5. So 16 minus 60, it's gonna be 44, which is less than 0, right? And I told you that whenever d is less than 0, then you get imaginary roots. Now, I just told you that if roots are imaginary, then they will occur in pair, right? And they both will be imaginary. Now, since this equation, this first equation, and this second equation are having at least one common root, so that means since in this both are imaginary, so in this also now both will be imaginary, because only one imaginary root is not possible. So if we have at least one common root, then they will both have common roots. They will both be imaginary, right? We will have conjugate pairs for them. So that means if it has one common root, so instead of one, they will have two common roots now. So if this is having alpha and beta as roots, this will also have alpha and beta as roots. So that means the sum of the roots will be same, because if roots are same, the sum will also be same. So sum you find out by minus b by a. So for the first equation, it will be minus 4 by 3. For this, it will be minus 7 by a. So upon solving this, you get a equals to 21 by 4. Product will also be same. So C by A will be equals to 5 by 3. So A is 21 by 4. We have found that out. So C will be 35 by 4. You have A, you have C. So in order to find C minus A, just 335 by 4 minus 21 by 4. So that is how much? 14 by 4. So that is 7 by 2 or 3.5. And this is how you solve it. Okay, cool. Let's see one more question. Find the number of values of m. M is less than 200. M is a natural number. That means it needs to be greater than 0. And the equation mx square plus 2m minus 1x plus m minus 2 is 0, for which roots of this equation are rational. Try that out. Now look, in this we are given that roots of this equation are rational. And I told you that whenever the roots of the equation are rational, that basically means, where did it go? Yeah, D is a perfect square, right? So let's do that. Let's find out D. D, that is discriminant, not equals to 0. D is B square minus 4AC, which is 2m minus 1 square minus 4 times A minus C. Right, let's expand this. Minus 4m minus 4m square plus 4m minus 4m minus 2, so that is 8m. So this we can remove, and this would be 4m plus 1. So now I could just use the hit and trial. So if I put m equals to 0, this will be 1. So you have one root. Okay, but this is not possible because m is a natural number. So no, m cannot be 0. Let's put m equals to 1. So this will be 4 plus 1, 5, which is not a perfect square. M equals to 2. So that will be 9. 9 is a perfect square of 3. So we have one value. Now you can continue this till m less than 200, but you will find a pattern. And with that, I want you to try that. You will see that there are total 13 values for which this is true. Go ahead and see those values, find those out, right? And I want you to do that. Let's see a few more things. Again, you have this equation ax square plus bx plus c equals to 0. This is having roots as alpha and beta. Okay. Now, in the question, if it is given that if new roots, instead of being alpha and beta, if they are alpha plus k and beta plus k, then new equation with these roots will be a times of x minus k square plus b times of x minus k plus c equals to 0. So root is alpha plus k, so you will replace it with this x, but not plus k, but x minus k, because you will write it like this: alpha plus k equals to x, so alpha will be x minus k. So that is why you will replace it with x minus k. Similarly, just like this, if your new roots are alpha upon k and alpha by k and beta by k, then your new equation that you have, it will be a times of xk square plus b time of xk plus c equals to 0. This will be your second equation. Similarly, on continuing this, if new roots are alpha square, beta square, then your equation will be like this. It may or may not be quadratic now because I mean roots are given like that. So let's say if your new roots are alpha cube, beta cube, then your sorry, not root x, but it would be x to the power 1 by 3 because you will write alpha cube equals to x. So alpha would be x to the power 1 by 3, right? So yeah, this would be b x to the power 1 by 3. This has to be square plus c equals to 0. If your new roots are 1 by alpha, 1 by beta, then your equation will be a times of 1 by x squared plus b times of 1 by x plus c equals to 0. Now this might look that how this is happening. I was having plus minus, so just write it down. 1 by alpha equals to x, so alpha will be 1 by x. So just replace this. Just like if your new root is alpha plus k, x, alpha equals to x minus k. What is alpha? X minus k. Replace that. Got it? Now if you look at this equation, if you just expand this, then it would look like this. Just an observation. I mean, you do not need to remember this, but just an observation that there is. Okay. Let's see one more thing. The last thing that you need to know in quadratic equation. That is maxima and minima of quadratic equation. I'll just write that down so that it doesn't confuse you. When you make a graph of a quadratic equation like this, ax square plus bx plus c equals to 0, when you make a graph of this, which is essentially a parabola, right? We have seen it multiple times again and again that it is a parabola. That is like this. A is greater than 0. This is minimum point, right? It's the lowest point. But if A is less than 0, then in that case, this is the maximum point, right? If this is the chart, if you are making this graph, then this is lowest. But opposite, if you are making this graph, then this is highest, right? Top of the mountain. Cool. Now, as that is clear, how do I find this point? How do I find coordinates of this x and y? It is actually very, very simple. The maxima and minima both occurs at x equals to minus b by 2a and y equals to minus dy 4a. This. So the coordinates are minus b by 2a comma minus dy 4a for any maxima or minima. In a greater than 0, it will be minima. In a less than 0, it will be maxima by default. So let's say if you are given a question, find, okay, not find, but if f of x is 6x squared minus 5x plus 28 equals to 0, find minimum or maximum, whatever it is, value of f of x. How are you going to do this? You have this equation. Product of AC is what? What is the product? So either you could find roots and then just go ahead and find that x and everything, or you could use my trick. That is minus b by 2a comma minus dy for it. Not my trick, it is very well known, so it's not my thing. Nothing like that. So we need to find the value of f of x. That is y. So what is y? Y is minus d by 4a, minus d by 4a. So that is minus b square minus 4ac by 4a. Can I expand it like this? Minus b square by 4a plus c. Yes. Can I write it like this? Now this would be minus 5 square because b is minus 5. 4 multiplied by 6. C is 28. There you go. So this would be 24 by 24. 25 by 24 plus 28. You can find this out. What's the sum? And that would be it. So 24 multiplied by 28 will be how much? 32, 3, 8 is 16, 3, 19. This would be 48, 2, 9, 8, 17, 1. This is 6. So 25 plus 6, 7, 2. So 7, 9, 6. So 697 by 24 is your answer. Cool. No, we have made a mistake. Actually, this is minus, right? Negative sign. So this will subtract. So 12, 5, 17, 7, 3, 4, 6. So this would be 647 by 24. This would be your answer. Let's see one more question quickly. The last one for today. And this I'm leaving up to you to solve. I'll drop the solution or the answers in the comment box. Okay, so at the top of the comment, you will find this answer for this in a few hours. Okay, before the next lecture is uploaded. So this is the question. Solve it, try it, and see if you can find that. And I will attach the link of this particular solution in the comments. If you like this video, just hit a like button so that it reaches to more people. This is the question that you need to solve. Okay, if fx is this equation ax square plus bx plus c equals to 0, what is the new equation if roots are reciprocated? Then, okay, this is the wrong thing that I have written. Then halved, not lived. And second is the roots are halved, then reciprocated. So this is something that you need to solve. The battery is low, and I'll see you in the next lecture.